Hi guys, it's Mrs. Seitz. Today what you're going to be working on is how to justify statements of congruent segments. So some words that we're going to define first before we move on is a theorem and a two-column proof. We've used these words before, but just to formally define them, a theorem is a true statement that follows as a result of another true statement, and it has to be proven and used as reasons in proof. A two-column proof is a method of a mathematical proof to present a logical argument using a table with two columns. And again, we've used these words before, but we're going to formally define them now. So in this particular exercise, we're going to take a look at some properties that we've worked with equality, but now we're going to be using them with congruence. So there was that reflexive property, and the reflexive property from before says for any segment AB, you can say segment AB is congruent to segment AB. So it's like the same thing on both sides. So I kind of think of that as like you have just one thing on each side. It's exactly the same. The symmetric property is kind of like what I say is like looking in the mirror almost, but you have two different things. It's kind of like flip-flopping things around. If segment AB is congruent to segment CD, then flip-flop it around. Segment CD is congruent to segment AB. And then we have that middleman property from equality, but it also works for congruence, the transitive property. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then cutting out the middleman, segment AB is congruent to segment EF. And again, that middleman that we're cutting out here is segment CD. So that's that middleman. All right, it's really important to notice that there's not a substitution property for congruence. Really important. Substitution property only works with equality, and the reason for that is because we're talking about numbers and we're talking about specific measurements. When we're talking about congruence, we're not necessarily talking about specific measurements and numbers. All right, here's another important fact that we're going to be using as a reason and proof, the definition of congruent segments. Two segments are congruent if and only if they have the same length. And that helps us to go sometimes in between equality and congruence whenever we talk about proof. All right, so let's take a look at this first example. So we have a picture of a triangle. All right, and it says, for example, given that LK is equal to 5, JK is equal to 5, and we know that segment JK is congruent to segment JL. We want to prove that segment LK is congruent to segment JL. So the first thing we always want to do when we have a two-column proof is before we start marking up everything, let's write down the given statements. So let's write down that LK is equal to 5, JK is equal to 5, and we have segment JK is congruent to segment JL. And it's really important to notice the markings that you see here. You notice that there's no segment sign above LK and no segment sign above JK because we're talking about equality. But when we talk about congruence, you have to make sure that you have the segment sign above it with the congruent symbol. Okay, so those are important things to note. All right, the reason for this is that it's given. And something you might want to do if you have some colored pencils, you might want to get those out, or if you have a highlighter, because then that would be really helpful when you mark up some things with proof. All right, so let's write some things down that we know. We know right now that LK, so the bottom length right here, is 5. We also know that JK is equal to 5. And we also know that segment JK is congruent to segment JL. And what we're eventually trying to prove is that LK, so that bottom one, is congruent to segment JL. Well, kind of by looking at it, you can kind of assume, well, hey, if the bottom one and the one on the right is equal to 5, and I know by marking off those tick marks that those ones have to be equal as well, it kind of seems obvious, but I actually have to show that segment JL is equal to 5 before I can actually get there. So it's kind of like working in between congruence and equality to get there. All right, and I'm going to show you guys how to do that right now. Okay, so here's one thing that I'm noticing. If I look up here in this statement right here, I see that LK is equal to 5, and I know that JK is equal to 5. So what I'm going to do is I'm going to go ahead and make this statement that LK is equal to JK. And the reason why I'm going to do that is because I'm going to cut out that middleman of 5 and go right into saying that LK is equal to JK. And since I'm cutting out the middleman and because I have equal statements in there, I'm going to say that that's the transitive property of equality. And it's really important that you make sure you write either an equal sign or a congruent sign. And since I'm using equal signs, I got to write equality there. Okay, so then the next thing that I'm going to do, since eventually I want to end up with some sort of statement that's talking about congruence, I need to somehow think of a way to go from equality to congruence. Well, that property that we just talked about, that definition of congruent statements, or I'm sorry, that definition that we talked about, that we're going to use a ton. It allows us to go from equality to congruence a ton of different times. And it also tells us that we can go from congruence to equality. So what I'm going to do is I'm going to simply write down LK as a segment, a congruent sign, and then segment JK. So all I'm doing is writing that same statement, but basically with a congruent sign. And I'm going to write definition of congruence. Or you can write definition of congruent segments. They mean the same exact thing. And again, what that does is it takes you from equality to congruence. And the reason why I want to do that is because eventually I want to end up with congruence in my final answer. Okay, so then the next thing I'm looking for is, well, I know eventually that I want to end up that LK is congruent to JL. And if I'm looking here, I've actually got some things in my given and that last statement that I have that can actually help me get there in the next step. So let's look what we have here. I have that segment JK is congruent to segment JL. And I also have something here with a middleman of segment LK being congruent to segment JK. Do you notice here that you have your middleman? Look at segment JK. You have that repeating in both of those. So you can actually take out your middleman right now of segment JK, and we can go right into that last statement and say that segment LK is congruent to segment JL because, well, what's that one about middleman? It's that transitive property. But this time, since we're using congruent symbols, we have to use congruent symbols when we talk about the transitive property. And you can abbreviate. So we're going to say the transitive property of congruence. And I'm even going to use that symbol there. All right, so again, to go back through, I wrote down my given. I marked up my drawing. I first showed that LK was equal to JK by cutting out the middleman of 5, right, through the transitive property of equality. Then, by saying that, I went from equality to congruence, which we're going to use a bunch with this definition of congruence. Then I noticed with my given in my last statement, I had a middleman of segment JK, cut out that middleman, and got right to what I was trying to prove with the transitive property of congruence. Now, this part here is not on your notes, but it's kind of important since we talk about equality and congruence so much. All right, equality, you have to have measurements, which means you're going to be talking about numbers. So a perfect real world example of that would be Mark and David are both 6 foot 2 inches. Okay, so remember that's talking about equality or using the equal sign. Okay, congruence is talking about perhaps like a name of a figure or a part. So when we say Mark and David are about the same height, okay, we're just talking about their height, but we're not necessarily talking about specific measurements. Okay, just to kind of give you the difference between those two. All right, so let's take a look right now at your next proof. So this time we're given that segment AB is congruent to segment BC. So I'm going to write that down. I'm going to go mark that up right now. So AB is congruent to BC. I also know that segment BC is congruent to CD. Okay, I also know that AB is 3x minus 1, and I know that CD is 2x plus 3. All right, and I'm trying to prove somehow that AB is equal to 11. So you can see I'm starting out with some congruence. I have some equality, so I'm somehow going to have to shift between congruence and equality again. So it's going to seem like I'm probably going to be using that definition of congruence again. All right, so I'm going to start out, this time I'm going to start out with just maybe 2 of my givens. And just because I know I'm going to be using that definition of congruence to shift between congruence and equality. So here I go. I'm going to say right now just that segment AB is congruent to segment BC, and BC is congruent to CD. And my reason is it's given. So I use this one and I use this one. Okay, right now, right off the bat, I see something that's being copied. I see this and I see this. So I'm going to make another statement by cutting out that middleman. I'm going to say that segment AB is congruent to segment CD. And since I cut out that middleman, and once we're talking about congruence, I'm going to say that's the transitive property of congruence. Okay, so I know eventually I have to shift over to equality. So I think I'm going to do that right now. And I'm going to use that new property that we just learned. So I'm just going to rewrite everything. I'm going to drop my segment sign. I'm going to make my congruent sign into an equal sign. And I'm going to drop my segment sign over here by saying AB is equal to CD. And I'm going to say definition of congruence or definition of congruent segments. Either works. They're the same thing. It's just 2 different ways to write it. All right, so now that I did that, let's see what I can use. Well, I actually know some things. Let's see. I actually didn't use that second part of my given, so I'm going to state it here. And again, you could have stated it at the beginning if you wanted to just get it all over with so you didn't forget anything. I'm just going to put it in right here because I just think it makes a little bit more sense logically. Okay. All right, so now that I did all this, okay, what I'm going to start doing, and I'm going to move this over here just because I'm running out of room, okay, but I know right now that AB is equal to 3x minus 1, and I know that CD is equal to 2x plus 3. Because I have this statement here of that AB is equal to CD, and I know that AB is equal to 3x minus 1, and I know that CD is equal to 2x plus 3, I'm going to take this 3x minus 1 and I'm going to substitute it in. And I'm going to take this 2x plus 3 and I'm going to substitute it in for CD. Since I'm talking about substituting things in, I'm going to be talking about the substitution property. Okay, so what I'm going to do for step 5 is I'm going to say that 3x minus 1 is equal to 2x plus 3. And since I'm talking about equality, I can use the substitution property. Sorry, guys. It's a little messy. Substitution property of equality. All right, the goal is to try to prove that AB is equal to 11. Okay, so I'm going to start solving for this. So let's see, I'm going to subtract 2x from both sides. So if I'm subtracting 2x from both sides, let's see, I'm going to get that x minus 1 is equal to 3. Okay, so that means I use the subtraction property of equality. Okay, so since I'm running out of room, I'm going to go to the next slide. You can keep writing on your note taker. All right, so my next move is I'm going to be adding 1 to both sides. So I'm going to get that x is equal to 4. So that's going to be the addition property of equality. All right, so I got that x equals 4, but I don't think that that's what I was trying to prove. I'm trying to prove that AB is equal to 11. Well, I know that AB is equal to 3x minus 1. So I think what I'm going to do is I'm going to make a statement in my next statement that's using that 3x minus 1, maybe with the substitution property. So I'm going to say AB is equal to this. It was what, 3x minus 1? I know x is equal to 4. So I'm going to say 3 times x, which is 4, minus 1. And I'm going to say that that is this, again, the substitution property of equality. And since, again, I'm using equal signs, I'm allowed to use this property. All right, so now my next move is I'm going to simplify this to get my answer for AB, and I'm really hoping that it's equal to 11. So 3 times 4 is 12, 12 minus 1, yep, it's 11. And what did I simply do to get that? I simplified it. All right, so 9 steps, but I got there and I justified every single step along the way. Okay, in our next proof, it's a little bit different. We've got some segments that we've got going on, okay? So when I see segments, I'm kind of already kind of thinking ahead that we might be using some segment addition postulate, but let's just kind of read through and see what we've got. So given we have Q is the midpoint of segment PR, and we're trying to prove that PQ is half of PR, and we're trying to prove that QR is half of PR. So let's go through our process like we normally do, and let's mark up our drawing, and let's also write down our givens. Okay, so our given is that Q is the midpoint of PR. And the reason is it's given. Okay, and well, what's some things that I know if I have a midpoint? Well, if I look at that drawing, I know based on what I learned before, if I have a midpoint, I can say that PQ is equal to QR. So I'm actually going to write that down. PQ is equal to QR. And I know that because that's the definition of a midpoint. All right, now I know I'm running out of space here. I'm going to try and squeeze one more little statement in here. All right, so here's the next thing I'm going to write down because this is what I'm kind of thinking ahead. I know if I add up that whole entire thing, so if I take PQ and QR and I add it together, I'm going to get that whole entire length PR. And the reason why I maybe want to start talking about that is because I know at the end I have to start talking about PR. So I probably want to start maybe getting PR somehow involved in this proof. All right, so I know if I add up the two small parts of the segment, it's going to be equal to the whole entire thing. And that is through segment addition postulate. All right, the reason why I wanted to put those two together is because I'm going to actually go over to the next slide, okay? For step 4, I'm going to show you what I'm going to write down next. And I want you to think about how I could say this because it might seem a little bit weird. So for step 4, I'm actually going to write PQ plus PQ is equal to PR. So to go from step 3 to step 4, so let's look back. The only thing that's different is I put a PQ in place of this one QR. Okay, well, how did I do that? Well, look right here. At step 2, I kind of said that PQ is equal to QR, right? So I'm going to put in a PQ in place of a QR. And the reason why I can do that is because I'm substituting it in. So I'm going to say by substitution property that I can say that. So substitution property of equality lets me do that. All right, so now let's start thinking about this. I'm eventually trying to prove that I have like PQ, a PR, all right, and somehow a half has to be involved somewhere. Well, I have PQs, I have PRs, so let's see if I can simplify anything here. So let's think back of some algebra. If I have PQ plus PQ, how many PQs do you have? You have two, right? So I'm going to write 2PQ equals PR. And all I was doing right there, I mean, some people might say it might be distributive property, right? Because you're technically combining something. You can say you're simplifying. I'm going to say I'm simplifying that. All right. I'm almost there. Look what I need to prove, right? I'm going to go back. I need to prove that I have half a PR. Well, I'm real close. Okay, I got to get that 2 on the other side. So what operation is separating this? Multiplication's in between here, right? So how do you get rid of multiplication? You got to divide. So here I go. I'm going to make the next statement. PQ is equal to half of PR. And the reason, well, I'm dividing both sides by 2, right? So that's going to be the division property of equality. The last thing I'm trying to prove, I got half of what I'm trying to prove. I'd have to say that QR is equal to half of PR. So this actually is going to maybe help me out. This step 2, I actually think it's going to really help me. So look here. Do you see how we're saying PQ is equal to QR? That's actually going to help me right now. So instead of me saying PQ is equal to half of PR, I'm going to be lazy right now. I know PQ is equal to QR, so I'm going to just plug a QR here in place of PQ. And I'm going to say it's also equal to half of PR. And my reason is it's going to be that substitution property of equality. Okay, so we just did 3 proofs together. Okay, we used some of the properties from before. We threw in some segment addition property, some definition of a midpoint, but the big one for today that you're going to be using a lot that's going to get you from congruence to equality is this definition of congruence. Okay, and I'm going to go back to it and where you saw it in your notes. Okay, so this definition of congruent segments right here, that's the one that gets you from equality to congruence.